Welcome back to another episode of the MacGyver Institute of Ninja Technology. Today I'm going to show you a quick video on how to make all the necessary calculations for your battery-powered devices. This will work for anything that's DC powered. You might even be switching from a wall plug power source to battery power so you can take your device out into the field. And you're going to need Ohm's law to do this. And here's the equation for Ohm's law. You have V for voltage, I for current, which is amperage, and R for resistance. So this will make a lot more sense here in a moment when I show you the next drawing. So if you wanted to figure out voltage and you didn't know what that was, but you knew what the other two items were, your current and your resistance, voltage would equal I times R, or amperage times resistance. If you wanted to figure out your amperage and you knew the resistance and the voltage, your amperage would be voltage over resistance. And then lastly, if you wanted to figure out resistance and you knew the other two, resistance would be voltage over current. So we'll move on to the next drawing and this will all make sense to you. So before we go too far, let's discuss what voltage, resistance, and amperage are and what they mean when creating a battery-powered device. So voltage is going to be your battery, and resistance is going to be a resistor. Go figure, right? A lot of different things can act as a resistor, such as a long piece of wire. A cup of water has a certain resistance. The human body has a certain amount of resistance, but for the sake of simplicity, use a resistor. They're super cheap. You can get them at Radio Shack for like a nickel. So here we have a resistor. And then amperage is going to be related to the device that you're powering. And every device has a desired amount of amperage, especially with a light bulb, as you can see here. If you were to overpower this, it would just blow the light bulb out, and we've all seen that. So we're going to put amperage here. So in basic terms, you could think of electricity as almost like plumbing for water. So if you wanted to power your hose nozzle, we could consider that the light bulb. And then the resistor would be the equivalent of the hose in between your faucet and your sprayer. And the battery would be a water pump, essentially. So it gives the force through a certain amount of resistance to power a device. Now the resistor, it does exactly what it sounds like. It resists current. So if you have a resistor with a very big value in ohms, then it takes a lot of power to overcome that resistor. If it's a very small value, then it takes a very little amount and it does little to affect the amperage. A large resistor equals less amperage, regardless of what voltage you add it to. So in this case, we're going to pretend we're powering a light bulb, and we'll say that it requires 9 volts and it requires 200 milliamps. And so you have to kind of start from the back here and say, what am I powering and how much power does it need? Now we know it needs 9 volts, so we're going to just use a 9-volt battery. Why not? And so at that point, we know how many volts we need, we know how many amps we need, and these are all labeled on every device you purchase that you're going to power. It will say supply voltage and how many amps it needs to run it. So now that you know voltage and amps, as we discussed on the previous page, you can now calculate your resistance. Now I'm going to show you a really cool app called Ohm's Law. Now let me get that out and I'll show you why it's so cool. Okay, so I've downloaded this free app called Ohm's Law in the Google Play Store. Go ahead and click on it. And you can see the table here. It gives us voltage, current, resistance, and power. Power being watts, like how many watts does your light bulb put out. That's a measure of heat. And so now that we know our voltage is 9 volts and we need 200 milliamps of power, we're going to go ahead and enter that in and see how much resistance we need to create 200 milliamps from 9 volts. So we'll go ahead and enter the voltage as 9, and the current, we're going to do that in milliamps, so we'll select milliamps and go ahead and enter that in as 200. Now we hit calculate, and that tells us that we need 45 ohms of resistance and that it will emit 1.8 watts of heat or power, however you want to see it. So now we know we need a 45 ohm resistor to create 200 milliamps at 9 volts. Perfect. Now we can make a circuit. So I'll turn this off and I'll show you how that's going to apply to what we're doing here. Okay, now that we know we need 45 ohms of resistance on our resistor here, we can now go ahead and create our circuit, and this battery should power this light without blowing it out, and it should be a wonderful situation. So as you can see, we have the positive post of the 9-volt battery, and we have our resistor. Now resistors can be forwards, backwards, doesn't matter which way they're oriented, and they can go on the negative side or the positive side of your circuit. But for this case, we'll just put it on the positive side. And we'll use this orange to represent our positive side of the devices, since most DC devices come with a red and a black wire. Red being positive, black being negative. So now that we've connected that, you just connect your other wire over here, and this light would run. And that's awesome. And now you've created your own circuit. You've got your device working properly without blowing out. And then if you just want to add a switch to it, you simply would place an inline switch here on any one of these wires, the positive or the negative, and it might have a little toggle on it that looks like that and flips this way or that way. Now you've got an on-off switch with your light, your resistor, and your battery, and you can do anything you want. This is the same way you would do a fan, a light, an electric motor, and you simply would read the voltage and amperage that you need here and match it with a proper battery and resistor, and then you're good to go. So I hope that helps you out when creating your projects, and gives you a heads up and an easy guide to creating most things that you might actually need to make without getting too crazy. Have a good day. Thanks again for watching.